Hi, everybody. This is Mr. Folly, and welcome to Podcast 1.2 Alloys. We're going to talk about what an alloy is, alloy properties, and the two types of alloys that we deal with. Alloys, well, I don't remember my cartoon trivia too much, but I remember adamantium, or was it vibranium or something like that? Well, vibranium was in Black Panther. I assume that was an alloy, but Captain America's shield and I think Wolverine's claws were both alloys. But anyway, let's hop into it. An alloy is a mixture of two metals. Okay, there are surface alloys like galvanization with a layer of zinc so that iron won't rust. An alloy can change the chemistry, which changes the reactivity. So iron is, believe it or not, a pretty fragile metal. The reason why it's fragile is that it can be attacked by oxygen. Remember, oxygen's diatomic. And when it attacks it, boom, it turns it into this weeny, terrible compound called rust. Fe2O3. And when it does that, rust is red. Not that that's a bad thing. And it's crumbly. Sorry, all right, you gingers out there. And weak. And that's not typically what we want out of iron. So what we do is we do this process called galvanization, where we put a layer of zinc over the iron that we are trying to protect. So iron is strong, it's got good properties, conducts electricity and stuff. And what we do is we put a little layer of zinc. Zinc, 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 zinc. I didn't look at the size of zinc to see if these sizes are right, but if I put a layer of zinc on it all the way around it, then what happens is zinc is not um, does not turn into a red crumbly thing when it reacts with oxygen. When zinc reacts with oxygen, it turns into something very hard and unreactive. So we like zinc. Zinc is a great galvanization product because it will protect the iron inside. There are two types of alloys. One is an interstitial alloy. Interstitial means between spaces. Hey, there's your Latin experience for the day, probably. I don't know what stitial really means, but you can tell me if that's your Latin experience when you get it. A small atom fits in the spaces between a larger metal. So different atoms have different sizes based on the periodic table. You've got yourself a little periodic table here. Whee! This right here is the biggest. This right here is the teeniest. And that's basically, you don't need to know that, but just as a general idea here. So not all atoms are the same size. Some of them are smaller. So if I have this one in black and it's got these spaces in between, you can put other atoms, or sometimes they get in there if you don't want them to. They'll fit in the space in between. Now notice density, if you remember, is mass over volume. Do you see how this interstitial alloy will increase the mass, but the volume is the same? What will that do to the density? The density will increase. Okay. If you think of this as being flexible, so a column of this and then a column of this bending, in order for it to bend, these things have to shift and use that empty space to crunch a little bit, right? If there's less empty space, it's going to be less flexible, which is less malleable. That's kind of sort of the same thing. Okay. Um, Ductility is kind of sort of the same thing, which means turning it into wires. Okay. And yeah, and the ductility increases. And what it means to be ductile, it means its ability to turn into wires. Okay. Now steel, which is iron big atoms and carbon the little atoms, has carbon fitting inside. Do you see how that would make it more dense? That would make it less flexible, and that would make it a better building material. When they found this alloy to make steel, then bam, what happened? They could now build skyscrapers. Before steel, you couldn't build a skyscraper because we didn't have building materials strong enough. So, yay, steel. A substitutional alloy, a similar sized atom replaces or substitutes an atom of roughly the same size. The density is similar. The flexibility and conductivity is similar. There's some other properties that switch a little bit. Brass is an example of this. And copper and zinc are very close to each other on the periodic table. And, whoops, I won't go back there yet. On these, if I were to pick which ones these would be, an interstitial alloy would be something from here typically with something from here typically. Okay. Alloys are mixtures of metals with a blend of properties. What, am I done with interstitial or substitution alloys? I am. That's pretty much it. Alloys are a mixture of metals with a blend of properties, so they mix those properties together. You should be able to draw an interstitial alloy. Interstitial means between spaces. So you draw big atoms when you're doing that, and you draw little things that fit inside. Okay. Draw a substitutional alloy. And then draw one that's roughly the same size. Okay. Predict which elements will do which type of alloying. And then remember we learned big, little on the periodic table. And if they're closer, they're going to be similar in size. That's it. This is a quick one. Hope you enjoyed it, and enjoy the rest of your day. Toodles!